This is Raycasting Basics 2. Now, I've already done a raycasting video where you raycast from an object. So go back and find that video. It should be in the programming playlist. Okay. Cylinder, hitting a cube, hitting a sphere. Okay, so I've already done the first one on raycasting from an object. So what I'm going to do today is raycasting from the screen and from an input mouse position. Okay, so I'm just going to start with a completely new blank fresh scene. And let's save it as raycasting from screen example. You can call it whatever you like. Okay, let's create a script for that. Yeah, I've done something funny to my mono. I don't know what I've done to my mono. What mono? That is out of red. Okay, so we want to cast some rays. Let's bring up the Unity scripting reference. Okay, so we're going to be casting from a mouse position. Okay, so we have the result here, input mouse position, and pretty much there it gives you the whole script straight away. Okay, so we're going to be casting a ray from the camera main. You can look that up to find out more about what camera main is. The first enabled camera tagged main camera. Okay, so if there's no cameras tagged main camera, it's going to return a null. In most cases, it'd be safe to assume you have a main camera. So you're casting a ray from the main camera. Now the command is ScreenPointToRay. And where is that position on the screen that we're going to cast a ray from? The input mouse position. Here you can put any vector 3. I could say vector 3, 0.5, yeah, 0.5 on the Y and 0 on the Z, and that would always cast from the center of the screen. But generally you want this for input mouse position. So let's build this out. And I'll also put the debugs in like I did last time. So we're going to be casting var ray. And this is going to be a type ray. It's going to equal camera main screen point to ray, and that position is the input mouse position, lowercase m, capital P. Var hit, just be our raycast hit, because we will be gathering information and returning information. And then the usual physics raycast. Okay, so if physics, I'd better show that in the scripting reference, hadn't I? Okay, oops, okay, so what are the parameters? Oh, there's heaps of them. Okay, an origin and a direction. The point I'm getting at is when you assign a ray, you are casting an origin, that's this part, and a direction in here. So I'll go to the scripting reference again. Physics raycast. Ray, that's what we want to be looking at. A ray is an infinite line starting in an origin and going in some direction. So a ray variable is actually an origin and a direction. So if we look at raycast, normally we had to separate. We had an origin, like the transform position. We had the direction, like the transform forward. And then the hit info, and for how far does that ray cast. Now if you're using a ray as a parameter, that already has a origin and a direction. So you have the origin, direction, and the hit information. There's a better example. Origin and direction in the one ray variable, the hit information that's going to be collected, where it's stored, and the distance of the ray. Okay, so let's just finish typing this in. If physics raycasts, and we have our ray, which is an origin and a direction, and our hit information we want to return. And okay, let's just go ray distance and make that 10 units. Ray hit and cast it for the distance in that variable. So if that returns a hit, let's just do our debug log. Hit hit point, and let's also get the name. Hit game object. Hit collider. The collider that we hit. Collider, and the game object that collider is attached to, and its name. And we're also going to do a debug. Draw ray. Vector 3, vector 3 color. That's the start and finish I want, and line is origin, direction, color. Let's check our debugs again. Debug. Okay, draw a line from a point start to end. Okay, ray is point and direction, so we want to draw a line because we've got the hit point. So we'll just get debug draw line. Now, where's the ray going to start from? Well, we're casting from the camera, aren't we? So let's just start this debug at the camera dot main transform component and the position variable of that transform. Okay, that's where it's starting, and it's finishing at the hit point of the raycast. And let's just color. We did hit something, so let's capital there. Color dot red. Okay, let's just make that happen. Now, if the raycast didn't hit anything, let's do a debug draw ray. Now we have to give it an origin and a direction for this draw ray. And that sounds familiar already, doesn't it? Draw line, draw ray. Okay, start position and a direction, and the color and the duration, which we're not going to bother with because we're going to do it every frame that doesn't hit. So, we already have a ray. We've cast a ray from the main position and the input mouse position. So our ray is our origin and our direction. And does it work like that? Start and out direction. Okay, no. See, I've gone no. That's a wrong one. Alright, erase that last 30 seconds to a minute out of your head. We're starting just like we did here. The camera mains transform position. Camera main transform position. Okay, and the direction would be the camera dot main and its transform component and its local directional vector of its forward. So that is our position, our direction. The camera is facing forward, so we're just doing the camera forward, and we're casting that for a distance of ray distance. Okay, I've got the closing parentheses. Alright, let's save that out. See if anything's happened. No appropriate. Yeah, the draw ray, isn't it? The color. Let's get a color in there. Transform forward. I see what I've done. Okay, we want the direction as a distance as well, and then the color. Yellow. Let's see if I've got that right. Okay. So yeah, I should recap on that. Draw ray from a position and a direction, but the direction has a length in it as well. That's just a vector with a magnitude of 1. Okay, so the forward times the distance, and then the color we want to draw it. Okay, let's make a little scene and see if we can get this working. So our ray, let's create a game object, put that script on, and what's this? The raycasting from screen example. That's a lot to type out again. Just copy that. And yet, let's put that on the camera. Well, we don't have to put it on the camera because it's calling the camera main. It's going to look for the main camera tag, the first one it returns. We can just zero out this object. Okay. Attach the script to it. Save the scene. And we'll hit play. Okay, so we found our camera. Okay. Now I was on the right track before. I even erased this whole line from our head too. So we have a direction which is the ray direction. So the ray direction. Okay, let's go back to the scripting reference. Where's the definition of ray? Did I bring it up? Okay, a ray. When you define a ray, it has variables. It has an origin and it has a direction. Okay, so let's even implement the origin in where I've gone here. So let's just say instead of the camera, going from the ray dot origin. Okay, I think that's exactly what I want. Finally, now we should see the ray starting in a different position when we're casting. There we go. If I zoom in closer on that camera and the view fustum, that's the near point clipping plane. This is where the ray is pretty much going to start working in the real world. And now you can see it moving across that square surface, okay, from where we're casting it from, and in the direction we're casting it to. Okay. Now I will use this ray in the next video. I wasn't going to mean to do this yet, but what I was going to do is set up a collider, create a cube, just put it on the camera so I can zero it out to the camera, because this is going to be like our static area, and I'm going to push it back, so let's just say 2, 1, there we go, our whole screen's covered in cube. So create a directional line. I've got to get up close to see this. Okay, it's past the view fustum. Okay, so now if I hit play, there you go, that was the point I was getting at with this whole video. So it's red, the ray, and it's showing the point where it's hitting on the object. And that ray is actually originating from the camera point. So let's fix that up again too. I just wanted to make some videos today, so this is just purely on the fly. We're having fun. Okay, so if we're drawing a line, let's just do the same thing here instead of the camera main transform position. We're going to use the ray and the origin variable of the ray. So now we should see that happening. There we go. That little square on the screen, that's showing where we're casting the ray from. And the hit point in the world space. Okay, well, I've already shown a lot with the ray. So what if we wanted to make this cube our cursor object? We can do that quite easily. Let's just set up a variable for it first. Cube cursor. And let's just typecast this of the transform, because we're just going to be modifying the transform position. The ray distance of 10, that looks good. So all we have to do, we're going to be using the ray, aren't we? So we don't need the hit or anything like that. That was just a hit example. So we're going to say the cube cursor position equals it's going to be the camera main transform position plus No, it's not. See, I've done it again. I'm so used to typing that. Okay, alright, blah, 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 blah. The cursor cube position is going to be the ray and the origin of the ray, plus the ray direction variable of the ray, multiplied by our ray distance. And that's what we're going to do. Okay, so in just 2 lines, we should have made our cube into a cursor. Let's see if that's working. Alright, of course, before it breaks, I better assign the cube in the inspector, because I haven't tried to find it or anything. Let's see what's happening there. Okay, wow, look at that. Now, it's not hitting any surface. We're not using a raycast or anything like that. We're just using the input from the camera's main and the input mouse position on that screen. And we're casting a ray from that point in a direction. And at a set distance, we're placing the cube. That's all that's going on there. So there we go. Okay, so I should explain that all finally slowly and clearly. We have a ray variable. In that ray variable, it stores an origin and a direction. Now, how do we create a ray variable? From all the way back here, from an input mouse position. Okay? And this is how you construct the ray. Use any camera you want. By default, using camera.main will find the main camera tag. Okay, so you can use any variable for a camera you want here, and the command is ScreenPointToRay, and you cast from a vector 3 input mouse position. But the screen's 2D, so you leave the Z at 0. Well, it's up to you how you want to cast your rays. So that's how you build your ray, and then from that ray, it calculates in itself these variables. What stores the origin, which is where it's cast from, the camera main ScreenPointToRay, and the direction. Okay, that's all done in this magic command here, ScreenPointToRay. So again, with 2 lines, you can create a ray that's cast from the camera's main, and it's using the input mouse position to do its all its calculations here. And then you drag out its ray origin and its direction, multiply that by a distance, how far away from the camera, and just set your object's position to that. And that is the result. Okay.